All right, you guys, this is going to be a series of videos for beginner board in basic solar. We're going to start with the absolute bare bones basics of a solar system and what it is and what it does. It's not near as complicated as it's made out to be. So, with that said, I have a mock solar system here with some bus bars. We have a 24 volt, 540 amp hour IFLA here, which at 10% is going to need 54 amps. We have a piece of shit PWM 60 amp controller, 24 volt. I've run this thing at 50 amps and it actually did okay. It's when you raise the voltage on these is when they get squirrely. So we have our solar coming into our charger, black and red on the solar side, and then we have the battery hookup. And right now I just have this all wired, very basic, no shutoffs, no fuses, no nothing. So we have the solar coming into the charger and we have the wires going to the battery. So I want you to think of a solar system has two parts. There's a charge part and then there's the AC part. So it's two separate, completely separate systems, and I'm trying to separate that with this visual from the understanding part that it's two separate systems. What I have sitting here will charge that battery the way it sits. Okay, now if we want to do work with this, we would need an inverter, at which point the inverter would wire into the bus bars, red to red, black to black, and that would give us the second part of our solar system, and that's the AC side. So we have the charge side is your panels, your charge controller, and then obviously we're charging the battery, and then we're using the bus bars as a central distribution point to distribute the 24 volts around your solar system. Let solar in, let DC out to make AC. So with our inverter here, we have 120 volt AC, usable house AC coming out of our solar system. This is absolute bare bones solar system. Now with that said, everybody has their preferences with shutoffs, disconnects, fuses, breakers, all that. And if you ask what you should do, you're going to get 6 answers of one thing, 6 answers of another thing, and probably 3 people itching to just hit the button and block you if you're on the main board. But we're on the beginner board here. So I'm going to lay out some of the basics as far as fusing and shutoffs, breakers, where there's kind of a rule of thumb for some basic stuff. So with that said, you usually want some sort of breaker on your solar. Okay. So I'm going to just pause this and set up the next round. Okay, we're back. Okay, so some basic disconnect and fusing that is kind of standard is, okay, you can see I put a breaker here, and then I have some fusing. Now, if I had a string of solar over here, I would pick the proper fusing and I would fuse it before it comes into the breaker, and that goes into the charge controller. Okay, this gives me a way to shut off the solar going into the charger if I need to shut it down, and or you obviously want to size this amp wise to your solar array. Okay. This may be a combiner box outside. There's a million different ways to do this. Again, why we can't tell you what you need to buy. But usually you want a breaker going in from the solar. Okay, so we have the solar into the charger. And then we're bringing our battery hookup here. Now, in between the battery connection, now this is a breaker, but we'll call this a disconnect. Just because I don't have any. And then we have our big fuse. So now in my system, this is a 150 amp fuse, okay, because I'm dealing with 3,000 watts, 3,500 watts. We're going to get to some math shortly and some homework, right? So I'm fusing the battery before I bring it into the central distribution point. So the battery has a fuse coming into this, okay? And we love our bus bars. Then you have your inverter still hooked up to the bus bars. Now, again, you can fuse that inverter. You can circuit breaker that inverter. You can disconnect that inverter. You can put in that line anything you want. Most people just wire them straight in there. So this is kind of bare bones. Basic solar. This has your fusing in it. Probably your baseline of what you need. Again, this would be a disconnect. It could be an Anderson connector. That's considered a disconnect. It's the same thing. But some sort of way to just break the battery off from the bus bars without you having to get in there with a wrench and unbolt it on a hot battery, right? So some sort of shut off there. So this is your bare bones, basic solar. You can add to this. If I want to add, I'm gonna reset and come back. Okay, we're back. So now the bonus to bus bars and doing the individual component setup is you can always drop in more. So let's just say I started it with this little setup. I wanted to add some more solar, went and bought a little bit better controller to add into the system. I put some more solar up on the roof. I've run that into the charger. And then this would just also run right to the bus bars, black to negative, red to plus. And we would send that in there. And again, we would need the proper breaker or shut off and fuse that we would want to put in there. But that would add that solar into the system. And just as easily on the AC side, I can stack another inverter. And again, wire that right to the bus bars. And that's all going to work. I'm going to have AC out of both of those inverters, all coming off of our central distribution point, is what we're doing with the bus bars. Some guys have these things 10, 12 feet long and think it's a dick measuring competition. Other guys just kind of order some stuff off Amazon and go with that route. So this is a component level solar basic right here. This is what it looks like. This is what it looks like as you grow. And again, if we're adding more chargers, there needs to be breakers over here and then the proper fusing from the battery. We went through that already. As far as the MPP and the PWM, if you just got a battery in your shed and you want to get some volts in it, I used this thing for like 5 or 6 months and I was stuffing way more amps in it, probably 50 amps. And it did all right. It did get a little hot midsummer when it was really juicing, hotter than it probably should have been. But it did fine parallel. I had another situation on a buddy's lot where the controller went and I threw one of them in just to keep it going, but we had the panels wired at 100 volts, and in 3 days, just like Dave was literally saying a week before, I had to laugh, that thing went haywire and was sticking 34, 35 volts into that battery and wouldn't shut off. So they do not like the high voltage. If you just go parallel with a few panels, I had really good luck with this Mr. Powell 60 amp piece of shit. I like the Evers, are a good product. So that's what we got. So let's move on. We're going to move on to hybrids and the difference of what that looks like. So I'll be right back. Okay, we're back. So now on the table, I have set up a hybrid, which is the charge controller and inverter all in one. Now, the main difference with this type of setup is that our central distribution point is actually internal on this equipment. So again, in theory, as we walk through what we just went through, we have our solar arrays, we have them fused coming in or in a combiner box, however we do it. We bring it in, and then we have our disconnect here with the solar going into the inverter. I'm going to use all my stats here, so because we're going to get into some Ohm's law and some live bullet stuff out in my solar trailer in the next video. So I have the stats on here and what I'm dealing with. So 24 volt, 3000 watt inverter. And then this is high voltage. We've had a lot of discussions on the boards about the voltages, and this is 120 to 400 volt DC. The higher voltage is definitely something that is going to work better. The larger systems you get, the guys running the really big stuff, they're either using the AC coupling and doing the end phase, or they're running the high, SMED running the high volts. Saves a lot on the wiring. And we're going to get to some Ohm's law and some of the wiring stuff in a minute. So this is what it looks like when you get a piece of equipment that your central distribution points for your battery voltage is internal. So as you can see, we have the solar coming in, we have the shutoff there, then there's the battery line, and then I put the disconnect. Again, that can be an Anderson plug, whatever, and then we have our 150 amp fuse going to our IFL. 540 amp hour, 24 volt battery. Then the AC comes out of this box, boom. And it does make it a little more simple. It's going to be a lot more upfront costs. But that's the difference between a component level setup and what you need to consider when you're wiring it and you're sizing it and kind of what it looks like. So you can get a little picture in your head. Now let's say you start with this, and in a year you're like, man, this thing, I sure would like to run a mini split in the shed, and I don't quite have the power in this. So we can actually add bus bars to this and create a secondary central distribution point, and start feeding in or out off of that. And I'm going to set that up so you can kind of look at that again. Let's just use a scenario. You built a system in your garage, boy, now you'd like to run the pool off of a separate inverter, right? Something like that. And I'm going to set that up and come back. I'm going to add the bus bars to this type of setup and show you what this looks like. Okay, we're back. Now it's getting a little busy here, but I added the bus bars to the system using the all-in-one. So again, my scenario is the all-in-one's maxed out. I needed to add some more solar, so we hooked that to the bus bars. Battery side, we got a fuse going in before it touches the bus bars. We got a fuse and a shut off before it goes to there, and then we have the battery fuse on the feed. That's the big one. That's 150. That would be 152 with 3,000, 3,500 watts. Again, this is just our shut off in reference. But what we've basically done is we just basically made a central distribution point, and now we're feeding that central inverter off the distribution point so that we can connect in either more solar or connect in to take more DC out in the AC side. So that's kind of how bus bars can come into play if you already have something like this and want to add, usually small. More often than not, you're going to add another one of these with this type of setup. But just to kind of give you a visual on how you use the bus bars to create a point where everything kind of clicks in, and then whatever each individual component, you have to again, fuse and disconnect and do it one at a time to get it where you want it. All right, let's move on.